Physics of external ballistics. First, to understand about exterior ballistics, we need to know what the definition of external ballistics are, which are the forces affecting a projectile from when it is launched to when it hits a target. Um, generally, to understand exterior ballistics, we need to understand the technology as weapons progress throughout time, which are as we get farther into more recent times, the farther armies are to shoot at each other. So the factors affecting a projectile's trajectory, I'm going to break this up into two categories. We have the changing factors and the constant factors. Constant factors are the projectile or the bullet. So the weight of the bullet stays the same throughout all the ammunition. The coefficient, um, the type of bullet, and the spin drift, and I'll talk about all those later, as well as gravity, which always stays the same, and the Earth's rotation, which stays the same. And then on the changing factors, we have air density. So kind of under those points are humidity, barometric pressure, and altitude, which all kind of affect the air density, and then the temperature of the wind, which are all affected by the location and the climate of the area. So to go into the constant factors, we have the bullet or the projectile. So the bullet weighs the same throughout that whole container of ammunition. Um, as well as the bullet coefficient, which is constant throughout all bullets. It's calculated during the manufacturing of the bullet. The coefficient is basically how well the bullet travels through air. So how well it breaks the air. And then the bullet spin, the spin rate or the spin drift. Then, of course, gravity stays the same, 9.8 meters a second. And then the Earth's rotation. I find this the most mind boggling factor out of all of them because currently the longest shot ever taken in combat is about 2 miles. And and the time it took for the bullet to travel 2 miles was 10 seconds. And so when you do the math, the Earth rotates 460 meters a second. So times 10 is 4,600. So the bullet traveled 4,600 meters east in the same time it traveled that same distance. So 4,600 meters east is about 2.8 miles. And so the shot traveled just as far east as it did traveling the direction it was fired in. But this factor is only considered when the bullet is fired north-south direction. So if it's fired east to west or west to east, it doesn't matter because it's running parallel with the rotation. So if it's traveling perpendicular, that's when the factor is taken into consideration. Next are the changing factors, which are a little bit more difficult because it's always changing based on the location and the climate. So first, we're going to do air density. So it's the mass of the air, and it's directly proportional by the barometric pressure of the atmosphere. Um, the humidity is the wetness of the air. It is directly proportional to the temperature. The temperature affects the humidity. Um, and so the wetter the air is, the more dense it is. And so the bullet is not going to travel as far or as fast as it was to a more dry climate. The barometric pressure is similar to the altitude, um, but it is calculated by gravity, altitude, and temperature. So it's kind of all the bottom two combined. They all affect the pressure, and so the more pressure it is, the more compact and harder the air molecules are, and so it's harder for the bullet to break through the air when there's a higher pressure. Altitude, very similar. Higher the altitude, the thinner the air, so the bullet's going to travel faster, and then the thicker the air is, the bullet's going to travel slower. Temperature, um, so when it's hotter, air molecules expand more, so it is going to travel faster. As more of a colder climate, the air is going to be denser, and so it's not going to travel as far. And then wind is the hardest factor to adjust because it's always changing. Um, it's also hard because it depends on the direction. So if it's more of a headwind or a crosswind, you got to kind of affect that into the trajectory of the projectile. So those are all the factors um, that affect external ballistics and the calculations that snipers and their spotters or long distance shooters have to take in consideration to properly approach and hit their target.